this screw is tight. And yet, even though this is tight, why can I take this barrel band off? There's a common thing that gets destroyed. This happens to be a Mauser 71/84. We're gonna look at what it's gonna take to fix this, tell you why it broke, and how to not do it to your gun. We've also got to make a screw for this. Small stuff, day-to-day crap that happens in a shop. Let's get down a rabbit hole. All right, I got the whiteboard up because I've got to show you the force diagram here. It will not make sense when you watch me make these parts. So we have a barrel band here, and what we want is a clamping force this way. We want to clamp it, right? So one side of this thing is threaded. This side over here is threaded. So let's go ahead and draw some threads in here. That is the hole, it's the threads, right? This side over here just has a hole in it. So in order to do this, we've got a screw. Here, we're going to do the head on the screw, slot, right? And it's threaded. And then it has a stud sticking through it. And that's what you usually see, is the screw with the stud sticking through it. What's missing is this blob over here. And everybody gets this backwards, because watch what happens here. If you take this screw, and I'm going to go ahead and redraw it in here. If you push the screw into this hole here, and it's threaded in here, and I'm going to run the threads out, and here's the head on the screw, and then there's a stud sticking through like this, okay, and here is the swivel. The tendency is to want to take this thing and screw it down tight and wonder why it doesn't work, or worse, attempt to pull this out. If you put the head on this, and I'm going to have to redraw this, I'm caving everything in here, hang on. Oh, make that go away. So I'm going to start over again here and get you a clean drawing, because hell, it's starting to confuse me. If I have a threaded fastener here, threads, threads, and I have a blob on this end of the threaded device, as I back this out, this is going to push up against that. This is going to push up against that. And there's our clamping force. So what will happen is people either try to back this thing all the way out and they'll break this head off, or they'll run it all the way in and they'll break that head off. This is a captured setup. This is designed so that it cannot come out in the field and get lost. Same thing happened on the back end of that gun. There's another swivel that goes back on the trigger guard. That screw is also gone. So it's a beautiful 71/84 Mauser. And before C&R Arsenal takes it out to the range and shoots with it, we're going to make a couple of parts here. We'll just jam through this and we'll get on to something else. As with most things German, this is needlessly overcomplicated with lots of little itty bitty bits. All right. So this screw comes out. This is just to get the barrel band off the back. See, I dropped that. Thank God I'm not in a trench somewhere. Because without this little eeny weeny screw, we go nowhere. All right. This guy comes out. I'm going to very gently pry on it. Always be conscious of the fact that your hose is going to finish up if you're not careful. All right, that's out. Now, the entire magazine tube's got to come out of this thing. So I've left the magazine tube on in order to get a little bit of purchase on the back of it. You can see it's starting to move. Now once it starts moving, now I can get back here. Now I can take the spring pressure off of it so that I don't unwind the magazine spring up inside this stock, and that is what that is. This is a beautiful piece of engineering, but boy is it made out of little itty bitty things here. Okay, so then that's unwound. And 2-ounce ball peen hammer. I'm not really hitting this very hard. I'm just assisting it in coming forward. Because BRUNO's a little bit I don't know, anal and a tad masochistic, he was nice enough to take this gun apart for me and dynamite all the rust out of it. Or else we would be using significantly more force than we are using right now. Okay. That comes, and in order to get the front barrel band and hence the rear one over the front sight, we must remove the entire magazine tube. This is a good time to do maintenance, boys and girls. Okay. So I'm just going to set that off to one side here. Bring the front nose cap off, set that down, and then we finally have access to the barrel band. So we can see here where, let me see, get it up against a decent background. There we go. When I take the screw out, the head's missing off of it. We'll pull in tight and we'll show you, but the head's missing off of it. So when it's in here, it doesn't matter how tight I screw this thing down or up, because we're always screwing things up, right? So let's run this in here. And it's even been cross-threaded ever so slightly. No matter how tight I wind this down, it doesn't draw the other side of this band back this way. It doesn't draw it back this way. So this, even though this works, this remains loose. What it needs is a head on it, so that as we're backing this up, like I tried to draw, as we back this up, it would, and I'm going to squeeze it with my fingers to show you what it would have been doing. It draws this together tighter and tighter and tighter. And now it'll pop right back open again. So not only do we have to repair the screw, but we have to repair it as part of this assembly. We can't make the independent parts and have it all made on a bench and then reassemble it on a weapon. The idea behind all of this complexity was to make this a single piece that was more difficult to lose. So why do they do this and then do all that crap on a 4-inch? Beats me. A public service announcement here, not public service, just a self-effacing mark comment here. Guys, I use a pair of dial calipers because they're accurate enough. I'm not making a machine tool here, I'm making a firearm. It's a completely different environment. All right, so I get it. I own micrometers, I own all that stuff, and when I need them, I break them out. But when I'm just going, is this bigger than that? These are good enough. In this particular case, this thread is a 255 by 27. It is not metric. I looked at the 0.8, 0.9, and 1 millimeter modulus, and they don't fit. The thread pitch gauge rocks back and forth in it. The 27 fits perfectly. So there is no way in hell I'm going to replicate this screw. It's not going to happen. So we're going to have to fix this screw. And what I propose to do is draw the temper off the top of this, turn it down flush, and then thread and insert and red Loctite another piece in, and it should hold well enough. To the work holding system and the torches, shall we? I have the screw I don't have it down tight. I have it just touched in here. And the reason for that is I don't want to wick all the heat away, but I want to draw any remaining temper off the top of this. Can we still see that? Yes, we can. So we're good there. We're going to go ahead and move this. There we go. That looks a lot better. And all we're going to do is we're going to heat the top of this screw up, and then we're going to let it cool off rather slowly. We're not going to quench it. We're going to heat this whole thing up. It doesn't matter if this thing's as soft as a piece of chewing gum when I'm done. But what I don't want to try to do, I see here that someone has attempted to drill a hole in the very, very top of this thing. Someone has thought about doing this repair before and just didn't quite have it. So hang on. Oh, more heat! More heat on screw. Oh. I'm going to take that sucker up till it's a dull red. There we go. You see it's starting to glow there. And then I'll start throttling the heat back. We'll hold it in that state for a little while. Dull red, maybe an orange. All right. So I'm throttling the heat back nice and slow because I want to start cooling this off very, very slowly. Now, because it's not in the vise very tight, we're not losing a lot of heat to the vise jaws. I'm going to let that sit there and cool off all by itself. I've switched vices, and I'm in my soft vise jaws, and now what I'm doing, and yes, I know the drill is in vertical, what I'm doing is I'm walking this hole into the center. But you see now, this thing is soft, 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 soft. There we go. This is just a 1/16 of an inch drill bit. And I have the luxury of getting that hole right in the center where I want it. I'll pile it down with this 1/16. Still haven't decided what we're going to tap it to yet. Yeah, we're going to go a lot deeper than that. This is a blind hole, and because it's a blind hole, we have to be careful that we leave enough room for the starting part of the threads in order to get down in it. Okay, here we go. So here comes an obvious question. Why aren't we doing this in a lathe? Well, how the hell are you going to hang on to it? If I was making this screw, I would have left the head part about that long so I could grab it, done all the machining, cut it off, turn it around. I don't have that luxury here, so we're going to have to kind of do it the hard way. Because I am gunsmith. Brute force did not work. Obviously, I did not use enough brute force. Must use more. I do not have a really good handle on this drill here. There we go. And yeah, I intend to drill this hole damn near down to where those threads are. I'm going in deep. You can't drill a hole through that. It'll make it weaker. Really? I'm turning it into a column. It makes it stronger. Oh boy, let the structural guys go after that one. Now where life gets too short is if you snap this drill bit off in this thing. That's where life gets short. Expletive deleted. Okay, I'm going to walk over to my grinder here real quick and kiss this. Leave it running. I'll be right back. All I'm doing now is squaring off the end of this hole here while I've got a moment. All right. And we're back. Okay. Let's see here. All right, so now what I've got to decide is what size screw do I want to put in that. And then we'll red Loctite. Red Loctite is some amazing stuff. When you put it on, don't plan on taking it back apart again. The blue stuff lets you take it apart. In our particular case, I would like this to become a single structural component. So I'm going to hunt around here and find the kind of screw I want. I'm going to mic this and I'm going to say, all right, I don't want to compromise the structural integrity of the wall, so there's a limit to how big I can go, but the larger the screw, the easier it is to tap. We'll be back. Okay, so I've got a screw stuck in here. See that screw popping up and down? What I'm going to do now is take this 648 screw and make the head diameter a little bit bigger. So what we're going to do, we are going to heat this whole block up and the top of the vise and everything. This is going to be a disaster. Make sure that's hanging on to that there. Let me shut this light off. I'll show you what I'm doing. I get the head of this screw good and hot, and you'll see when I pull off there, see how it's orange? That's what we're doing. But I got to have the lights on so I can see. So I'm walking the hammer around this way. So I'm dome heading this screw and I'm just flattening it out so it's larger in diameter. And I get the small threads I want with the big head. So there we go. You can see that the head of that screw is now 3 times the diameter it was. Put it in the lathe and clean it up, and then we'll tap the other hole. So while we wait for this thing to cool off, we'll go prepare the hole. Let me shut this torch down here before somebody hurts themselves. And that would be me. All right, 648 tap, and you're going to do a quick pan, and you're going to look at this, and you're going to come right back to me. Right there by my finger, see it? 648, the diameter of the tap's 138 thou, you got it? The drill diameter is a number 31, which is 120 thou, and there is no fractional equivalent. If we wanted the clearance drill it, we have these numbers over here. This thing hangs right in front of me. I don't memorize these numbers, I just look them up. So we're gonna have to drill the top of this screw out to that number 31 drill, which I have procured, and then we're just going to chuck this thing in the drill motor, which I think I left. What drill motor? Yeah, here it is, right here. Whoa, hang on. All right, so we'll chuck that in the drill motor. We're going to open up the hole to the right size. A little bit of lubricant in there. Now we're going to do an idiot check and make sure that this thing is the size of the tap, which I set down right here. Does that feel right? Yeah, it kind of does, but I'm telling you what, this drill feels a little bit big. So I'm going to make sure that this is 120 thousandths drill bit. And it is 120 thousandths drill bit. So what the hell happened here? Oh, here's what happened. Okay, this drill bit was hand sharpened by me after it was destroyed while we were making parts for the Pedersen device. And I'm going to tell you, the Pedersen device, cool AF, but I have never been happier to see a gun go back in the box and go back to its owner. So what this drill bit is doing is it's walking in the hole this way. It's not going straight down, it's coming in this way, and it was wallowing it out. And I saw that because that hole just wasn't getting it. So let me see if I've got another 120 thousandths drill diameter. That's a 105. This looks like a 120 right here. There it is. I have an entire tub full of, in this particular case, tap and die number 6. Let me see if you can see that. There it is. This is tap and die number 6, and it's got all the dies, the taps, and sharp drill bits in it. This number 31 drill bit we are going to store over there. Did you hear that hit the floor? Yes. That's so that it's no longer in the gene pool. All right. That's a 125. I'm going to get a little smaller. And we'll go ahead and we'll get this whole board out and we'll keep moving. So stand by here. Drill bits. There we go. Why can I not find 120 thousandths drill bit? Oh, there's one right there. Very good. Very good. We're golden. Right here. That's us. Good Lord, Mark, wake up. There we go. Now I'm on. I'm sorry about that delay. I don't care what it says on the drill bit. I'm actually watching. I'm looking at what the mic is telling me. There we go. That's better. Now, as you're opening this up, it'll be obvious. The hole will just stop moving. There it goes. It stopped right there. That's a deep-ass hole, too. Look at how deep that is. That's that deep. That's deep enough, right? All right, 648 temp. We got a little bit of oil. Guys, I don't plug products on this show, but when I talk about Acroglass, it's because it works and it's functional and it gets it done for me. This little tube of Lucas, oh my God. Like I said, I'm not doing product placement, but I'm telling you, as a tapping lubricant and working up inside of a gun, you cannot beat that stuff. It is absolutely whale snot. Anyway, said I'm not plugging anybody's stuff. The only thing I'm talking about is stuff that works. And it's not shameless. Okay. So we come back and we break the chip, come in, break the chip. You got to be very, very careful how much torque you put on this thing. Because if we snap this bit off, we are done. Done, like done with a capital D. Okay, here we go. You'll feel the torque wind up hard when it hits the bottom of the hole. It will just go, and you'll feel it. If it squeaks, you're done. All right, here we go. I'm pushing with both fingers and counter torquing this. I'm just trying to be really, really polite. Here, we get near the end. Yeah, that's the end right there. Excuse me. Okay, here we go. I'm just taking my two fingers and lifting up like this just so that when this comes out, it doesn't twist out. All right, then blow this down. I moved the camera, sorry. Why is this air hose kicking my ass? Here we go. Better? We got it? There we go. All I'm doing is blowing up. We'll just blow this out. Had a little bit of a camera move there. Sorry about that. I caught the air hose on it. Bruno was Johnny on the spot. Paper here. It's a little bit of 400 grit. I don't want to make this look too good because it's going on a 130-year-old weapon, for God's sakes. So in the aluminum vice jaws here, I've got the piece that we made trapped in the aluminum vice jaws so I don't crush this thing. And what I'm doing now is just test fitting and making sure that before we try to put it all together again, we got it all in one place, and we do. Because there's no way to put any torque on this thing without having it in the vice jaws. So here we go. There's the barrel band. Okay. So this will go through. That goes in there. All right, let me make sure that's going to squeeze. And then this goes in here. Let me get this right. Of course, like with most things that we video, the time to find out that something is screwed up is before you turn the camera on. But this is a day in the life. Here we go. Wow. Boy, somebody else had gone after this thing. I'm going to tell you what. I'm hanging on to it there, and I'm trying to get all this here to thread up, and it's not going through. So let's take this apart and find out why we're just having all this malaise here. What happened? It's out of round. Okay. What a pain in the neck. Yeah. Threads are getting screwed up. All kinds of crap's going on here. Well then, what in the name of Sam Hill am I going to do about that? Well, I've got a very, very aggressive wheel over here. So hang on a minute. You're going to watch me or listen to me do this. It's almost like a piece of metal got in the way and started hosing up these threads. And we don't want to do that. Those hosed up threads are the last thing we need. Kiss that there, and we're going to come right back. All right, here we go. So I have to get these threads to run And what I'm looking at from my line of sight is I'm making sure that this screw is going in perpendicular in 2 axes. Okay, it's got to go in perpendicular in X and Y so that I don't strip this hole out. It was starting to strip it. Here we go. So now I can run that in. Ah, there you go. You see now it's going all the way home. So I should have done this before I attempted to mount the bayonet. Put these things back together again in stages, I guess would be the only way to say this. Okay, so we'll pull this out. All right. Now we'll put the band in. We'll make sure it's free to move, and it is. Put that in. And then I'm going to get a clamp here. Ah! Gravity sucks. All right, what I'm going to do with this clamp is I'm going to squeeze all this gap out of it here if I can. I'm going to try to squeeze this through so that the end of that sticks out. Wow, this thing was hosed up. That's got to stick through. There we go. What I want is the hollow end of this screw to stick out here so that I have a place to attack it with that stem. And if it's not free to move, you'll never be able to put it together. God, I'm a hot sticky mess today. I just knocked my little clip clamp off there. So let's see if we can get up in here and cause that to be squeezed. I don't know here. Okay, I'm seeing what's going on here. The band, the swivel is taking up all the room, so the threads are actually pushing up against it. So the only way we're going to be able to get at this is to unthread it. And if we unthread it, the other side will collapse and allow me to do what I was trying to do, which is make this stick out. Wow. Now, when this was made originally, they would have heated this thing up with a torch and just made a little button rivet like we made when we did the 1919. There we go. See how that's in there like that? There we go. Now it's squeezing. So what I want to do is squeeze this together in such a way that we can work on it. So we'll leave that up like that. Okay, here we go. I'll do it up here. You see how that's coming together like that? We'll bring that together. And then we're going to take our little piece that we made, put little squirts of red Loctite on it, and be done with it. So, little spritz of the red Loctite. Yeah. I have almost no room to work on this here. This thing is going to kick my ass all the way out the door. But if we do this right, you won't know that we made a repair. You won't know that we did it. And the true pro can get in and get out. You never knew he was there. Okay, hang on here. Okay. Oh, what a pain in the butt. There we go. Now it's going in. There are these days when my fingers don't work, and I'm telling you what, you are getting to preside over a very, very low dexterity day. Okay, we're almost here. I have these days when gravity sucks, and this is one of them. We're almost there now. I'm going to pull this out, and I got to hold it in my hands so that I can get the last little bit of torque on it. There we go. Okay. So now we have a button head back there, the screw head back there, and in order to tighten the band down, we counterintuitively loosen it. In order to tighten this band, you would back this out, and as you back it out, it squeezes together. So you see it's totally squeezed together here, but as you push in this way, this gap gets larger and larger and larger. It's counterintuitive, and that's why these things get screwed up in the first place. There's a stud here, and there's a stud on the other side that is designed that when you pull this barrel band down, it's got something to push against. That's not screwed up, and it needs to stick out. So we slide that over, and we walk this screw out until we draw torque. We're almost there. We've drawn torque, and now the barrel band doesn't move, and we're in the game. It's maintenance. Not everything you do inside this shop is all that sexy. It's something as simple as just drilling a hole down the long axis of a screw. And as always, it's been a pleasure, guys.